So yeah, I almost killed my lab mates. That's not my research. I'd imagine getting that past an ethics board would be tough. But instead, driving down the LA freeway, looking for my exit, all of a sudden I see this billboard, California Science Center. Turn over to Greg and Ash. We have to go there. It's about at this moment that I notice that the car directly in front of me has come to a complete stop. I slam my brakes, slide, and we stop inches from the car in front of us. Now, we all have similar stories. Driving our car down the street, we're all bombarded by constant distraction, be it a billboard, a fancy car, our cell phone going off. Each of these distractions made as salient as possible to grab our attention. So my question is then, how is it that we're able to focus attention on things that we're actually looking for amidst all of these distractions? And so attention typically works as a booster. When we find the item that we're looking for, our attention boosts that item, making it more salient than anything else in our entire visual field. In turn, this item wins the competition for our full visual perceptual awareness. Now, what if this competition's a little bit more difficult though? What if I give you an item to find, but I place a really shiny, distracting object just right beside it? Does your attention always have to get captured by this item and boost this item instead? And it's funny, whenever you ask people this question, everybody's intuition is always the same. Everybody thinks that they're really distracted by shiny things. But it turns out this is actually not the case. By measuring the electrical brain signatures in people, what I discovered was that attention has more to do with than just boosting a signal. Paradoxically, attention also has to do with ignoring. And it turns out that when we have a really salient item that's attempting to distract us in our visual field, we send a signal to it to actually dampen that signal. The pattern of electrical brain signatures that we found reveal that the cells in visual cortex that would otherwise code this item are turned off. Now, for my PhD thesis, or the remainder of it, I'm looking to actually suss out exactly how it is this active suppression mechanism works. As someone who is given a childhood diagnosis of ADD, it's particularly important to me that I might be able to better understand why some people are more distracted than others. And in a world full of distractions that cause 421,000 accidents every single year, hopefully my research on attention has captured yours. Drive safely.